Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. This video shows VisualCAM 2016 for SolidWorks being used to machine a door panel using both 2.5 axis and 3 axis toolpaths. Without further delay, we invite you to sit back and enjoy the demonstration.
Okay, so what I'm going to do here is first go ahead and start up SolidWorks. We have SolidWorks running different versions. I have 2012 all the way up to 2016. So our VisualCAM module will run in SolidWorks all the way up to the latest release 2016. So we go as back as far as possible. So currently we can go as far back as 2010. So customers who are not on the latest version of SolidWorks can still run our CAM solution within SolidWorks. Our VisualCAM for SolidWorks is a certified gold CAM partner product for SolidWorks. It runs inside of SolidWorks 2010 to 16, and we have both 64-bit and 32-bit platforms available. So if you have a copy of SolidWorks that is 32-bit, runs on 32-bit Windows, you can still run our CAM plugin on it. Now, what I'm going to be demoing today will be VisualCAM 2016 for SolidWorks. This runs in SolidWorks 2010 all the way up to 2016. Okay, so when you bring in a new part into SolidWorks, when you select the new File New button in here and load in a new part, you will notice that the milling interface, the CAM interface, automatically appears within SolidWorks. You'll see a new tab at the top. It says VisualCAM 2016. And you will have access to milling and turning modules. So we offer two modules in SolidWorks: milling for 2 to 5 axis CNC milling and routing applications, and you have a 2-axis CNC lathe or a turning center. You can also add on the turning module to it. Each of these modules are licensed independently, so you can basically get the modules that you need for your application needs. You'll also notice that the VisualCAM entry appears under Tools, and then you'll see VisualCAM right up there, and you have the different modules. We have mill and turn, and mill is currently selected. So the mill browser appears right next to your Feature Manager design tree. So if you switch from your Feature Manager design tree to VisualCAM by just clicking on the tab, you'll see the mill interface, and as you drag the browser, the width of the browser, or resize it, you'll see the mill interface right in here. We have the machining operation browser, which appears right up here on the top. We have two main tabs: Program and then Simulate. And right underneath it, if you click on Tools, Machining Objects, you will find the Machining Objects browser, which allows you to create and load tools from your library. You can manage all your tools. You have machining regions, where you can predefine machining regions derived from the part. We have hole feature detection for drilling and pocketing holes, and we also have knowledge bases where you can load operations that you programmed and apply them on family of parts. So we'll go through the interface. We'll try to bring in one of your files and see how best we can, try to program it. Any questions so far?
No, I can't think of any.
All right. Now I did receive your files in here. So first, let's maybe start with the door sample in here to start with, and then we'll take a look at some of the other files. Would that be okay?
Yes.
All right. So I'm going to select the door sample part and then select Open. And VisualCAM's plugin will automatically run if you're working either in inches or millimeter units. If the model units that you currently have is not in one of these two units, it'll automatically say that its units is not being supported. So what we can do here in SolidWorks is go up to the units, and you can click on Edit Document Units, or you can just pick whether you want to work in inches or mmgs for millimeters. Do you have a preference on the units?
No.
Okay. Would you prefer working in inches?
Sure, that's fine.
Okay, so I'm going to change it to IPS, and there it is. The model units are now set to inches, and you currently have your units defined in inches. Now you should be able to program this part. Now the first thing we would take a look at is, once you import or load a part into SolidWorks, you want to make sure that the orientation from which you're going to be routing this part or milling this part is correct. So if you take a look at it here, looking down from the top view, you want to make sure that the z-axis is normal to that face, right? So the way you currently have it set up is your z-axis is normal to one of these faces. You can look at the orientation of the z-axis. So basically, you want to make sure the Z is rotated. So rather than having to rotate the part in SolidWorks using the move, copy, or transformation tools, what you could do here is in your machining browser, we have an option to click on machine, and now we can change the orientation of it. One of the ways to do it is using the spin angle and selecting the rotational axis, or you can even use select the surface. You can pick a surface or a face on the part, and you'll now notice that the Z-axis will be normal to that. So in this particular case, it's using the normals, that points to the bottom of the part. So if you want to flip it over, you can basically specify an angle in here, and you can say you want to flip it over by Y by 180. So basically a Z is up, pointing normal to it, looking from the direction that you want it to be, right? Once you establish that, you can also establish your X and Y axis orientation. So I want to have my X axis align parallel to this edge, and then the Y axis over to the other edge, and then you pick OK, and there's the new orientation of your coordinate system right there. So in just a couple of button clicks, you can orient your coordinate system. Any questions?
No.
Okay. In the next step, we are ready to select the machine tool you're going to be working with, and I'm told that you have a Shop Saver CNC, so we'll select the Shop Saver post from the list. We have two post processors, one's for the machine that have automatic tool changers, or if you have a machine that has a manual tool change, you can pick the Shop Saver with CNC from the list. Would you be able to tell us if the machine has an automatic tool changer?
Yeah, I have a tool changer.
Okay, so we'll pick the one with the automatic tool change, and I believe their extensions are .tap for output files. You can use NC or TAP or any of the preferred extensions, and then you pick OK, and there's the post processor defined right in here. So in the next step, we want to define our stock workpiece. We can click on stock, and we'll select box stock. So VisualCAM's mill module is offered in 4 different configurations. We have standard, we have expert, professional, and premium. Standard includes 2 and 3-axis milling. The professional configuration offers advanced 3-axis milling. It also includes 4-axis and positional or index 5-axis milling, so which allows you to program from multiple different orientations. Our expert configuration is basically the same as standard plus the 4-axis capabilities added to it. The premium configuration is ideal for programming simultaneous 5-axis machining, so it has all the features of the Pro, plus it offers simultaneous 5-axis milling. So we're going to be starting out with the box stock in here. So when you click on stock and box stock, and when you hit copy model box, the system will automatically compute the extents of your part that you got in here and let you know what is the minimum size of stock blank you would need for it. So it gives you a length, width, and height. Do you have a recommendation on what size you would like to use for it?
This is actually modeled incorrectly. This is actually a 5-piece. Those are 2 separate door panels that are actually individual parts.
Okay. So these 2 panels are individual parts right here?
This piece here would be one.
Okay, let me also go ahead and give you keyboard and mouse control so you can...
This is going to be about 15 pieces there.
Okay. So basically each of these it looks like an assembly of parts, right?
Yes.
Okay. So let's say, for example...
This model is an example.
Okay. Okay. So basically this is one piece in here, what I'm looking at right there, right?
Absolutely, yeah.
Okay, and I can see those joints in here, which basically have been, you may have used some mates in your assembly mode to, create it into one, assembled part, and then you export it at, you may have saved it out as a part, right?
Yes.
Okay, great. So let's say, we'll quickly go through maybe a couple of steps in here, and then we'll load in one of your individual parts and see how best we can program it, okay?
Okay.
So what I'm trying to explain or show here is the workflow, how you'll be able to program within SolidWorks using our CAM plugin. So once you establish the stock, the dimensions of your workpiece here, you could say your stock is much larger than the part. You may want to have maybe like a 28 by 28 inches so you don't leave a factory edge around it. Then you can also change the height or the thickness of the blank if you want to use a larger piece of blank so you can run like a facing operation to clean it up. So I'm going to pick OK here, and there's the stock blank as you see it right there, and there it is. There's your workpiece. Now the next step you want to do is align the stock to the part. So you click on Align, and you can choose to have it align centered so you can basically clean up or remove material from all the 4 sides. And then you pick OK. Now you got the stock defined. You have your post processor set and the machine is defined as 3-axis. In the next step, we want to establish the origin. So typically, when you're starting out with a rectangular blank, it's probably easier to establish the origin to one of the corners of the stock blank, or you could even put it in the top dead center as well. So if you want to put it to the corners, you can click on work 0 and click set to stock, and you can pick what corner you would prefer to establish your XYZ 0. So this is basically when you place this stock blank on your CNC table, you want to make sure you zero out to one of the corners, and all your toolpath's coordinates will be interpreted based on this corner. Any questions?
No.
Alright, so let's click generate, and there's your work 0 right there. And as you can see, each of the steps which you program are automatically displayed in the machining browser right in here. In the next step, you would like to program some toolpaths in here. So there's a couple of different ways you could program it. So let's say you would like to maybe pocket this feature in here. You can go up to 2-axis milling. Now, we have different types of milling techniques. The standard offers 2 and 3-axis milling. I'm not sure if you're familiar with the difference between 2 and 3-axis milling.
Not particularly.
Okay. 2-axis milling, or also known as 2.5-axis milling, is ideal for parts that are prismatic, which means there aren't any, drafts or sculpted bottoms. So where you can basically, the cutter will, remain at a constant Z depth as it travels in X and Y, and you can basically step it in levels. That's why it's called 2-axis or 2.5-axis milling. Now, a part like this is ideal where you can basically pocket this in different levels, starting from this top face all the way down to the floor. So you can use 2.5-axis operations and methods for these. So in this particular case, if I want to pocket this feature, I could use 2-axis and pocketing, and now I can select the feature to be pocketed. There's a couple of different ways you can select. You can use select curve edge regions, and you can right click on this edge, and you can do select loop or select chain, and you can basically pick which loop direction you want to pick, and I can reverse the direction of the loops as you see it right there. You can use those techniques in here, or you can even use basically just go grab these edges in here to select them for machining right there. So you can pick what edges you want to mill, or you could even say you want to use a flat area and pick the floor right there to pick those areas for machining. So there are different ways you can select features for machining in here, right? To program it. So in this case, since it's an assembly, you can see some of the edges are going past some of the other edges on the model right there. So you may want to have an edge that basically is restricted to these areas only. So you can also additionally create some sketch geometries if you'd like in SolidWorks by going into your sketch tools, and you can say you want to create a sketch on this face, and you can actually go put in a rectangular sketch, and you can basically grab these corners or endpoints that you want to use for the sketches, or you can even use the convert entity tool in SolidWorks to basically select the sketches that you want to use for defining these boundaries for pocketing or creating a pocketing operation for the toolpaths in here. So I'm going to pick these in here, accept those, and you'll notice that it created the sketch, and we may have to do some trimming in here, trim out these entities out right there.
I understand that.
So since the model here, it looks more like an assembly, what you got right there, so it wasn't probably intended for machining in one pass, we had to create these boundaries or regions in here. So once you have this selected, you just go up to 2-axis milling and you can select pocketing. You can see that the sketch was pre-selected, so it automatically was added to the part regions, and then you go up to the tool, and you could use whatever tool you'd like, and I have a 1/2 inch end mill, but if I'd like to go modify my tool properties, I can hit edit, then I can change the properties of the tool, specify my feet and speeds in the tool right here. I can also use the built-in feet and speeds calculator to select the material type I'm going to be working with. So if this is going to be typically wood, you select the material, and based on the tool material, Visual Mill will give you recommendations on feet and speeds. So if I want to cap my spindle RPM to 8,000, it'll recompute the cut feed rate, and then I can do a save edits to tool, and those changes are now being updated. Now the next step here is basically to go to feet and speeds. You'll notice that the feet and speeds are loaded. Your clearance can be set to automatic, which will ensure that it'll safely clear the maximum height of the part of the stock, whichever is higher. And then in the cut parameters, you can specify your cutting conditions. You can choose what type of cut pattern you would like to use, your step over distances in here. You can choose your cut direction. In the cut levels, you can actually specify your geometry location. What you selected is the floor of the pocket, so you pick at bottom. And then for the total depth, I can just pick 2 points. I can pick the top face right in here, and I can go pick the floor of the part. So it determines the total depth as 5/8 of an inch, and this 5/8 you can specify how you'd like to cut it. You could say you only want to go in steps of maybe 3/16 per cut. So it'll distribute it into equal passes. And then you can specify your entry and exit. These are all your lead in and lead outs. You can ramp along the pad. You can specify the ramp height in here, and you can choose the type of ramp, and then you hit generate, and it'll automatically produce your pocketing toolpath right there. So this type of technique is called 2.5 axis milling, where the cutter remains at a constant Z as it travels in X and Y. So it's basically pocketing or hogging all the material out inside that area. So now when you go to your simulate tab, you can select the stock material, there it is, and you can select the operation, and when you hit the play button, it shows the material removal in progress. You can also display your tool holder while it's simulating right there. So there's your pocket operation, which is basically hogging or clearing all the material out in levels or layers. And there it is. Now this is one of the ways to program the toolpath. Now if you'd like to automatically program all of the features in one pass or one operation, you could actually program it using like a 3-axis toolpath in here. You can actually basically just pick a boundary and just program it using a 3-axis toolpath. So one of the ways to do that would be, in this case, if I want to not cut past the extents of the stock, I can create a boundary in here. So I can go to 3-axis and choose horizontal roughing. And now, rather than picking just this boundary in here, I'm going to say select curve edge regions. And in this particular case, I'm just going to go pick these edges of the part that forms a boundary. Do you know if there are any gaps between the two ends?
No.
No, there aren't. Okay. So I want to make sure that the boundary what I select is a closed loop or a chain. So I have this selected right in here. I'm going to accept the selections. I'm going to go into my tool, grab the 1/2 inch end mill, set the feeds and speeds, set my clearance, and in the cutting parameters I can set my cutting conditions in here, and also I can control the step over and the step down, and then say pick clear flats. It'll automatically clean up all the flats. So in this process it automatically computes the roughing toolpath, and there's your roughing toolpath. So you can notice that the system automatically computed the toolpath based off the part and the stock geometry. So rather than program it as several different pocket operations, you can program it all in one operation like a horizontal roughing. So there's the roughing toolpath. So you can see that it's already roughed out in levels. So this is 3-axis and roughing, and then you can go ahead and process a finishing toolpath. Now once you have these toolpaths programmed, you can take a look at the estimated machining time on it. Right mouse button click and select information. Will tell you how long it's going to take to cut it based on the parameters that you specify. And then you'd want to do a post process. Right click and post and specify a file name, and by default it'll use the name of the part, and it'll post it in the same folder where you had the part located, and you hit post, and there's your posted G-code. You can now transfer this out to your CNC code. And the nice thing about working inside of SolidWorks with our CAM plugin is saving your part in SolidWorks automatically saves all of the machining information to the SolidWorks part document. Do you have any questions so far?
No.
Okay, so I'm going to do a save as, and I'll just give it a name here. I'm going to call this door sample revision 1. So all of the work that you put in is now saved into this part. Now one of the powerful features what VisualCAM offers is the ability to save all of these operations into a knowledge base. So when you have family of parts or parts that are similar to these that you'd like to program using the same workflow of operations, you can save them into a knowledge base. And I'm going to go ahead and specify the file name to be the same as the name of the part, and I'll save it in the data folder in here, and I'll select save. So now this operation I can load it on other parts I'm going to be working on.